All right, folks, this is the last lesson for Unit 10 in this awesome graphing unit. I say that facetiously. So 10.4, inverse trig functions. So we are going to look at the graphs of inverse trig functions, okay? So sine to the -1 or cosecant to the -1 and so on and so forth. The graphs, though, is just sine, cosine, and tangent. And then we're also going to find the value of inverse trig expressions using either the unit table or ClassCalc or reference triangles, okay? So either exact or approximate values of inverse trig expressions. All right, so let's talk about the sine inverse function. So you notice here it says the word arc sine. You will see arc sine or arc cosine or arc tangent several times in this lesson. So make sure you understand that arc sine means the exact same thing as that. Okay, so you're either going to see that one, you're either going to see this, or you're going to see this. Okay, it's either one. They just know that they mean the same thing. It's just like when you get f of x or y. Okay, it's the same exact thing. They both mean the exact same thing, just written differently. All right, so arc sine and sine inverse mean the exact same thing. So here is our sine function, and we're going to use this to determine our inverse sine function. Okay, so what I'm going to do is I'm going to focus on only a couple of points from our sine function. I've got this point, this point, this point, this point, and this point. So what are the values of those points? Well, the furthest to the left is -pi on the x value and 0 on the y. The next one is -pi/2 on the x and -1 on the y. Then we've got 0, 0, equilibrium line, or the origin where it starts. Then we've got +pi/2 giving us a +1 on the y. And then we've got a +pi giving us a value of 0. Okay, so those are 5 key points that I'm going to use for sine. Now, before I start graphing the inverse sine, I want to focus on this area over here, because this is what's going to matter the most when we start graphing. Okay, I am only concerned where sine is positive. So sine is positive in this gray shaded area here. Okay, so so we're only focusing on where sine is positive. Oh, I'm sorry, that's not correct. Sorry, this is the area where sine is positive. Sorry, not the gray area. That's the area where sine is positive, because sine represents the y value. Okay, so we're only focused on where sine is positive. So the quadrant 1 and quadrant 4 is where sine is positive. Now, what we have here is we have sine values that are both positive and negative. We have +1 here, and we have -1 here. We are only going to focus on this region right here, only where sine is positive once and negative once, okay? So we're only gonna focus on that region. So the reason why it is shaded gray is because we wanna focus on just where it's positive and negative, but it's right next to each other. I mean, we do have a negative sign in this area over here, but it's not adjacent to quadrant 1. So we are only gonna focus on quadrant 1 and 4 now, okay? So here's why we're going to use quadrant 1 and 4. Sorry, let me get my eraser. So the gray area symbolizes where we're going to be using, where basically the domain is of our function, okay? So we're using the values of theta, where just between, where theta is between quadrant 1 and quadrant 4. So only those values, okay? So if it's anything larger than pi/2, we're not going to use it. So nothing in this area. And if it's anything less than -pi/2, then we're not going to use it. So anything over here is also gone. Okay, so we're only focusing on, sorry, let's carve that out. We're only focusing on this area right here. So we're only going to focus on those points. Let me clean this up a little bit here. So if we're only going to focus on those areas, then we're only going to focus on these points, which are the middle 3 right there. Okay, so we're only going to focus on those 3 points, and that is super important for us to focus on. Anytime that we get a sine function, anytime, these 3 points are what we are going to use every single time. Okay, in terms of an arc sine or a sine inverse function. Okay, so here's how we're going to use that points. Remember what inverse means. Okay, if I have the point xy and I want the inverse of that point, then that means we're going to switch x and y. We're going to switch the y and the x together, okay? And we're going to get new inverse points. So when I do the inverse of the sine function, I'm going to take these 3 points within just the domain of quadrant 1 and 4, and I'm going to switch them. So my new points are going to be -1, -pi/2. 0, 0 switches to just 0, 0, and 1 +pi/2. So those are 3 new points from inverse of the sine function. So negative, and notice the x and the y-axis also switched between radians and regular integers. Okay, so that is going to be on your homework as well. So when it switches like that, it's because we're doing the inverse. So the x is -1, the y is -pi/2, so that's a point right there. 0, 0 stays 0, 0, and +1 +pi/2 is right here. This is the only 3 points we are going to graph. You are only going to be graphing 3 points for all of your inverse functions. Okay, even for tangent, you're only going to be graphing 3 points. So what this graph actually is going to look, if we were to keep going, let's say we were to keep going, I'm going to draw it in red here. If we were to keep going along this is what the inverse sine function would look like. Okay, it would look like this if we were to keep going, but we're only going to stick between quadrant 1 and 4 for sines. Okay, so this is what the inverse sine function would look like if it had no restrictions for domain and range. It would look like this. Okay, so it's just like an inverted or rotated sine function. So here's what we're going to do. We're only going to focus on just those 3 points. So we're only going to worry about from here to here. That's it. Okay, and you got to draw it imagining that's going to keep going. Okay, you got to draw it imagining that. So we got to cut it off with those curves there. So that is my inverse sine function. Okay, just that point right there, just those points right there. You are not going to have to answer domain and range questions for this, but I'm just going to show you just to show you what they mean. So the domain of the inverse sine function is just from -1 to +1. Okay, so we're only going to worry about when the domain for C, okay, C is going to be an integer that we're going to use for input, okay, so X in this case, but they use C for this, is only going to be from -1 to +1. And the range is going to be from this lowest point to that highest point. So the lowest point is -pi/2. And in this case, the range is theta. So because it's the inverse, so theta is between -pi/2 and pi/2. And that is where this comes from, because this is -pi/2 here. And this is pi/2 over here. Okay, so that's why the range and the domain, it's domain in sine function and it's range in the inverse function. Okay, that's why it's only between pi/2 and -pi/2. All right, you're not gonna have to identify that. Don't worry about that. Just know that for sine, we are using these 2 quadrants. Okay, for sine, we're gonna use these 2 quadrants. So let's look at an example of a sine inverse function that we're gonna have to graph on our homework and on the test. All right, so what I'm gonna do, just like I've been doing for any kind of transformation graphs, I'm gonna use red X's to determine where originals are. So again, remember our points. Okay, remember our points. Sorry, I went back too far. There we go. Hey, yeah, stop. Okay, so we're gonna use the same 3 points that I told you guys to always remember for sine. We need to remember the points -pi/2, shoot, I lost it, sorry. Where's my sine function? I'm looking at my notes and I can't find it. Where is it? There we go, -pi/2 and -1. 0, 0. Sorry about that delay. I couldn't find it on my notes. And we got pi/2 and +1. So this is for regular sine function. This is for the sine function. Okay, this is sine of theta. Okay, what we are going to now do is the inverse, which means we're going to remember these 3 points for the inverse. So sine inverse will always be the inverse of -1, -pi/2, 0, 0, and 1 pi/2. Always remember these 3 points for sine inverse, okay? Because those are going to be where my x's are going to go. Okay, those are going to be where my x's are going to go. So I'm going to use blue as my x's this time. Okay, I know I'm used to using red, but I'm going to use blue as my x's this time. So -1, -pi/2 falls right here. 0, 0 falls right here. And +1 pi/2 falls right here, okay? But now let's look, there is a 2 in front of this. when there is a 2 in front of your function in the very front, your a, when your a is 2, I know this means amplitude, but when we're dealing with inverses, this is what you're going to do. You're going to take this 2 and you're going to multiply every single y value by that a. Okay, every single y value gets times by 2. Okay, way back in units 2 or 3, I think, when we did transformations, we learned this. So it's just kind of a refresher, but it's still a little new. So what I'm really going to be plotting down, the x didn't change at all, it's going to stay. But the y, what's negative half pi times 2? That's negative pi. Okay, when I times 0 by 2, I still get 0, so that's going to stay 0, 0. And when I times pi over 2 by 2, I get positive pi. So these are my transform points using this 2 right here. Okay, so I multiply every single y value by 2. So my points I am plotting are the points -1, negative pi, 0, 0, and +1, positive pi. Okay, those are my 3 points that I need to graph, and this is what my function looks like. Okay, remember, imagine it going all like this. So we got to curve it correctly. We're only doing it restricted within that range right there. All right, so that is what a sine function looks like, and that's the process that I use to kind of help me figure out how to get there. Okay, so let's go ahead and focus on cosine next. So cosine functions, okay? Again, I'm gonna focus on 3 points, and I'm just gonna keep it within this right here. Oops, sorry, wrong one. I'm just gonna keep it within these 2 quadrants, okay? And the reason is I need to stick it between where pi and 0 are, okay? So for cosine, we only use when theta is between 0 and pi, okay? So it's only gonna be between here, here, and here, okay? Only from 0 to pi, that's it, only from 0 to pi. All right, so there's the only 3 points we're gonna use. So for cosine, we're gonna use the point 0, 1. We're gonna use the point pi over 2, 0, and the point, oh no, I did that wrong, sorry. That is the point 1, 0, sorry about that. No, that was right, pi over 2. I'm confused, I'm looking at this one over here, that's why, my fault. All right, so pi over 2, 0, and pi -1. So those are the 3 points we're going to focus on. We're only focusing on the domain given to us from here in quadrants 1 and 2. So from 0 to pi is what our domain is going to be for the graph of cosine. So for inverse cosine, we are going to flip all those points. So flip all those points, inverse all those points, and we're going to get the points 1, 0, 0, pi over 2, and -1 pi. All right, plot all those points down. So 1, 0 is here, 0 pi over 2 is here, and -1 pi is here, okay? So this is our function. It's gonna look like this, and imagine that the function just keeps going after that like this, okay, just like the sine function. So we do have to curve it accordingly. So that is what our cosine function looks like. And then again, just nice to know information, not need to know information. Domain in regular sine was from 0 to pi. So that means the inverse means the range is from 0 to pi. So theta goes from 0 to pi. And look at the domain. Domain is from -1 to +1, same thing. So the domain is C for the arc tangent, or arc sine, cosine, sorry. So from -1 to 1. Again, this whole column is nice to know information, not need to know information. You need to know how to graph. That is what you're gonna need to know. And these 3 points will always be your starting points. Or if you want, you can use these as your 3 starting points if it cuts out a step for you. Okay, those 3 starting points every single time for any cosine inverse function. All right, so let's use those 3 points to do a cosine graph here. So again, the 3 points that we are going to use for cosine inverse are, I keep forgetting to do my marker, sorry. Those 3 points we're going to be using from the inverse are 1, 0, 0 pi over 2, and -1 pi. Okay, every single time, these are my points I start with. So I'm going to start at 1, 0, 0 pi over 2, and negative 1 pi. Okay, so now what are we doing? What's the transformation we're doing? Well, it says here, this is h. We are shifting horizontally, and we are shifting to the left 3 units. Okay, so we're shifting all these points left 3 units. So take your top point, 1, 2, 3. Your new point is now here. Take your middle point, 1, 2, 3. It is now here. And take your bottom point, 1, 2, 3 is now here. And this is what your function will look like. Okay, so again, I always start with those 3 points for the blue right there for cosine, and I just transform it based on the function. All right, so now let's look at tangent. Okay, so let's not forget for tangent, we also have these vertical asymptotes, okay, for the regular function. Okay, these are all vertical asymptotes. All right, and for tangent, we're only gonna focus on quadrants 1 and 4. So that means we are only focusing from pi over 2 and negative pi over 2. So just like sine and tangent have the same restrictions. So our range is going to be from negative pi over 2 theta to pi over 2. Okay, so that hasn't changed, just like sine. And our domain is going to be, actually, look at what it's going to flip to. So our domain is actually going to be all real numbers, because it has to have a limitation. It's going to go on forever and ever and ever. So it's just going to be all reals. Okay, so here's what we're going to focus on for tangent. Which points are we going to focus on? We're going to focus on these 3 points right here. 1, 2, 3. Just those 3 points. And those 3 points are negative pi over 4, negative 1, 0, 0, and positive pi over 4, positive 1. So those are our 3 points from the tangent graph, and we're going to inverse all of them. So our new 3 points are negative 1, negative pi over 4, 0, 0, and positive 1, positive pi over 4. So those are our new points for the tangent inverse function after we inverse all the x and y's. So here are our points. Negative 1, negative pi over 4 is about here. 0, 0, and positive 1, positive pi over 4 is about right there. Our vertical asymptotes at negative half pi and positive half pi are going to be converted to horizontal asymptotes at positive half pi and negative half pi. So there are my my horizontal asymptotes now that it's an inverse function. And we just draw our graph like this. So an inverted tangent graph looks like that. All right, so that is how tangent looks. We are going to focus on using these 3 points whenever we do any tangent inverse function or arctan function, and we're going to use that to do any kind of transformations. All right, so let's see what that looks like. All right, so remember our 3 points for tangent are negative 1, negative pi over 4, 0, 0, and positive 1, positive pi over 4. All right, so I'm going to start with those as my starting points, my baseline. So negative 1, negative pi over 4 looks like this. 0, 0 is here, and 1 pi over 4 is there. So look at what we're doing transformation-wise, okay? This is not inside the parentheses, so this is actually the k. This means we're going to go down 3 pi over 2 units, okay? Remember, the radians are now the y-axis, so we're going to go down 3 pi over 2 units. And that's it. We're not doing anything else to this function other than moving everything down 3 pi over 2 units. If that's 3 halves and each of these is 1 half, then we're going down 3 lines, basically. Every single point's going to go down 3 lines. So this point, 1, 2, 3 lines goes there. 0, 0 moves here. And your top point moves there. All right, our asymptotes also shift down 3 units. So our asymptotes would have been up at the top at 1 and negative 1, but now they're going to be moving down 3 pi over 2 units. I should say pi over 2 and negative pi over 2. So there's our asymptotes, and we graph the tangent function, or the inverse tangent function. And it looks like that. Okay, so always start with these points for tangent and then perform your transformation. You're gonna get questions that have to do with shifting up, down, left, right, and maybe even an a that expands it. Remember, if your a is a certain number, multiply every single y coordinate by a, and you'll get your new y coordinates. All right, so that is how you do the graphing from this unit. All right, you're gonna have 5 or 6 graphs on your homework for inverse functions. All right, let us not forget our unit table. It will be provided in GoFormative as well, but if you have the hard copy version of it, have it handy because we are going to be using it today. Remember, in sine, we only worried about quadrants 1 and 4. So for sine, we only have to deal with, let's worry about, for sine, only in quadrant 1 and quadrant 4. So for sine, we only dealt with that. For cosine, we dealt with quadrant 1 and 2. So cosine, we'll do it in blue, is quadrant 1 and quadrant 2. And then for tangent, we also had quadrants 1 and 4, just like sine. So let's do that one in green. So quadrant 1 for tangent, and quadrant 4 for tangent. All right, so we're only it's too far. We're only focusing on these areas of the table, just these areas, because that's the only ones that matter. Okay, so if it says anything like cosecant or secant or cotangent, you got to know cosecant goes with sine, so it's in the same quadrants as sine. Secants go with cosine, and cotangent goes with tangent. You got to remember all that stuff. And we are going to use this unit table to answer these questions. Okay, once I clear this, this is not going to be here. So just know which quadrants we're looking at. All right, so let's look at how we're going to use this table. So these 3 values. We want to find the tangent value of the arc sine, oh geez, I forgot the marker again, of the arc sine of rad 3 over 2. So we are basically asking us, remember arc sine is the same thing as the sine inverse of rad 3 over 2. Anytime you are trying to find the inverse of a function, you are finding the angle. You are trying to find theta. So sine inverse of rad 3 over 2 is asking us, what is the theta value? What is the degree measure of when sine is rad 3 over 2? Okay, so anytime I ask you sine inverse, you are trying to find theta. You're trying to find the angle measure. So let's find the angle measure when sine is rad 3 over 2. Well, to do that, we're going to have to go and check our table. So when is sine rad 3 over 2? Remember, we're only looking at sine in quadrant 1 and quadrant 4. In quadrant 1, it's here. In quadrant 4, it doesn't exist. So this is the only one where sine is rad 3 over 2, and that is 60 degrees. So sine inverse of rad 3 over 2 means we're finding the angle, and that angle is 60 degrees. So this is now going to convert to the tangent. I forgot the marker again. Okay, stop it. The tangent of sine inverse of rad 3 over 2 is the tangent of 60 degrees. Okay, so we found out what the degree measure is. Now we got to find the value of tangent of 60 degrees. So we go back to our table. And where is tangent of 60 degrees? 60 degrees tangent is right here. That value is rad 3. That is what we put. So the tangent value of sine inverse of rad 3 over 2 is the tangent of 60 degrees, which is rad 3. That is our answer. That is how we use the table to answer these questions. All right, next one, arc tan of negative rad 3. So the tangent inverse of negative rad 3 means what is the angle measure that makes tangent negative rad 3? Let's go to our table. Where is tangent negative rad 3? Tangent is positive rad 3 in quadrant 1, so it's not quadrant 1. And tangent is also in quadrant 4, so we go to quadrant 4, and we got 300 degrees. So we got 300 degrees or negative 60, either one. You can use the positive or the negative. It doesn't matter to me. But 300 degrees is what we have for tangent inverse of negative rad 3. So if that is the value at 300 degrees, then we are asked to find the secant value of 300 degrees. So go back to our table. Secant value at 300 degrees is 2. So our answer is a nice, clean 2. All right, last one here for this version. So we're going to find the sine of the inverse sine of 1/2. Okay, be careful here. You could use the table if you want to, but let's not forget what inverse properties do. Okay, if I were to add 2 and then subtract 2, that cancels out. Okay, if I were to square root 2 but then square it, it cancels out. So if I'm going to do the inverse sine of sine, or the sine of the inverse sine, those straight up cancel out. So all we are left with is the value, 1/2. That simple. Okay, so if you are taking the sine of the inverse sine or the inverse sine of sine, they cancel each other out. 1/2 is the only thing we got left. All right, so that's how we use the table of values, or sorry, not table of values, the unit table to answer these questions. We're finding exact values. So you leave your answers in radical form, you leave them in fraction form. Remember, you cannot have a radical at the bottom of a fraction. Cannot have a radical at the bottom of a fraction. So please remember that. All right, let's go on in our lesson here. Finding approximate values using ClassCalc. So now we're just going to punch into ClassCalc. Here is my disclaimer alert. Okay, if it says inverse cosecant, you are going to set your ClassCalc to degrees because you are finding the angle measure. Okay, I'm going to say that again. If it says inverse, set your ClassCalc to degrees and find the angle measure, because anytime you're doing the inverse of any trig function, you're finding the angle measure. So we're finding the degree value. So go into ClassCalc, and we're going to type in cosecant inverse. Well, one, we're going to make sure our settings are to degrees because we're doing degrees. Okay, make sure it's degrees. And we're going to go trig cosecant inverse. Come on. There we go. Cosecant inverse of 2.67. And it's 21.9953 degrees. So 21.9953 degrees. Okay, pay attention to what settings you should be in, degrees or radians, and pay attention to your labeling in your answer. If I'm finding an angle, I need to put the degree sign. All right, number 8, it does not have the inverse function. So the only way we can tell if it should be in degrees or radians is if there is a degree symbol in these parentheses. If there is a degree symbol, leave your calculator in degrees. If there is no degree symbol, this is radians. Okay, so this means we need to convert our calculator to radians, and we're just going to type it in secant of 0.15. But it's got to be in radians. Okay, it's got to be in radians. So back to ClassCalc. Change our settings to radians, and we are going to do the secant. Forgot what the number was. Secant of 0.15. Let me type, why not? 0.15, there we go. And I get 1.0114. The 3 gets bumped up to a 4, so 1.0114. And we did not find a degree, so we do not put a degree symbol. Okay, again, it has to say inverse for us to find a degree, so make sure you guys understand that. So like number 9, inverse, we are finding a degree, so our answer should have a degree symbol. I'm going to write it now so I don't forget about it. And we are just going to straight up type in secant inverse of 6, but because we're finding a degree, our ClassCalc settings need to be in degrees. Make sure you keep track of your settings for ClassCalc. Always make sure you have your settings correct for ClassCalc. All right, so we are I forgot what we're plugging into the calculator. We are finding the secant inverse of 6. So secant inverse of 6. And we get 80.4059. 80.4059. degrees. All right, that is our answer. So that is how we use ClassCalc. Again, I cannot stress to you enough how careful you have to be with making sure your degrees or your calculator is either set to degrees or radians. Make sure you have it in the correct setting. All right, moving on. This is the last part of our lesson. We're going to use reference triangles to answer these simplification questions. Okay, so right off the bat, we're using a reference triangle. So I'm going to draw a reference triangle. Doesn't need to be in a coordinate plane. I'm just going to draw a right triangle. That's all it is. I'm drawing a right triangle. All right, and I'm going to put theta over here. All right, so this is telling us the sine inverse is 5 over 13. So it's telling us that what is theta if sine inverse is 5 over 13? Okay, well, sine inverse of 5 over 13. Let's remember, sine is the same thing as opposite over hypotenuse. So if sine inverse is 5 over 13, that means that the opposite of theta is 5 and the hypotenuse is 13. Our goal now is to find tangent of theta. So this implied that sine of theta was 5 over 13. Our goal now is to find the tangent of theta. We're going to use this triangle to find the tangent of theta. Well, tangent is opposite over adjacent. Do we know the adjacent one? No, we do not. So what we are going to need to do is Pythagorean theorem to find out what this side is right here. We're going to need to know what that is. So Pythagorean theorem, leg squared plus the other leg squared equals the hypotenuse squared. All right, so go ahead and simplify that and solve for x. We're going to get 25. I did double x here, sorry. 25 plus x squared equals 169. If you know your Pythagorean triples, you can go ahead and just answer this without doing all this work. That's why it's good to know your Pythagorean triples. And we get an x value of 12. So this is 12. So to find the tangent inverse, the tangent of theta, we do opposite over adjacent. That means tangent of theta is opposite over adjacent. Leave your answer in the form of a fraction. Leave it in simplified form. We are not doing the decimal version, okay? And that's all it's asking you to do. Find tangent of theta. Well, theta was giving us 5 opposite 13 hypotenuse. We use our Pythagorean theorem to find the adjacent side to do tangent, okay? Same thing here for secant. Draw another reference triangle. And it's a right triangle. It doesn't matter where you put theta, just keep track of your opposite, adjacent, and hypotenuse. All right, this is telling us that the cosecant inverse is 8 over 6. Remember, cosecant is the reciprocal of sine. So this is the same thing as hypotenuse over opposite. Okay, cosecant is the inverse, the reciprocal of sine. So our hypotenuse is 8 and our opposite is 6. So we need to now find out what that, and let's not forget secant is the reciprocal of cosine. So that would be hypotenuse over adjacent. So we need to know what the adjacent side is to answer this question. So just like last time, we're going to use our Pythagorean theorem. So leg squared plus the other leg squared equals the hypotenuse squared. Okay, go ahead. This is not a Pythagorean triple, so you are going to have to do this whole part out, and it's not going to come out clean either. So watch what happens when we don't get a clean answer. Oh, 28, sorry, not 24. When I square root 28, okay, I get a decimal. So when I get a decimal, I need to check to see if I can simplify this radical anymore. Are there any perfect squares that can go into 28? The answer is yes. 4 can go into 28. So this is the same thing as rad 4 times rad 7. If I can simplify the radical, I'm going to simplify it. Rad 4 is 2, rad 7 stays rad 7. So this missing leg here is 2 rad 7. Please be sure you simplify your radicals. Okay, it's a little bit of extra work, but you are going to have to simplify your radicals. All right, so let's go ahead and answer the question. Hypotenuse over adjacent. The hypotenuse is 8, and the adjacent is 2 rad 7. Remember, you cannot leave your answer when a radical is on the bottom of a fraction. You cannot do that. Okay, so what we're going to have to do is multiply top and bottom by the radical in the denominator, by rad 7. Okay, let's also not forget that we can simplify this 8 and this 2. Okay, all right, and when we multiply this out, we get rad 7 times 4 on the top, and we get 1 times 7 on the bottom. This is our answer in simplest radical form, simplified version. Simplify your answer completely for those. Okay, you are going to get some funky radical ones on your homework and on your test, so make sure you understand how to simplify your radicals and simplify completely so that you don't have a radical in the denominator. All right, that is it for 10.4. Get ready for your review and all that stuff and get ready to take that test, but please reach out if you guys have any questions on anything Unit 10 or anything at all. All right, have a good rest of your day.